Okay, good. What is the topic? The topic is digital twin for continuous security monitoring, and I will discuss what is security monitoring in this case. Okay, thank you. So, security monitoring of a security status of an industrial automation and control system. I take this term because this term is a very famous one in the standard IEC 62443, which is a standard for security in industrial environments. So it's in this case it's different to 27001. We discussed it this morning, but it addresses especially industrial automation control in 3 roles: for the owner, for the system integrator, and for the manufacturers. So, and I want to outline a vision. So I hope you do not expect too much, because I will not present solutions at the moment. Okay, good. So first we have to define what is the security status, and then we want to identify the necessary tasks. I can look here, I have to learn. And then we have to look at the challenges we have here. I think a lot of them you know if you work in industrial automation control systems, or I guess you work in IT, OT environments. OT is the abbreviation for operational technology, and means the technology we have in industrial and automation control systems. So, and then I will do some hints how solutions could look like. So then we go, I can do this. First, the definition of a security status. Okay, we have to look at environments. Can you see it here? Otherwise, I will do another picture. No, I think it's enough. I will explain that. So that is a simplified picture for an industrial automation control system. For example, we have here some Ethernet, industrial Ethernet rings, which connect to some controllers, which is PLCs, like for example S7 1200. And then a second ring, which is connected to this ring here. And if you are familiar with the Purdue model, we are here in the Purdue model level 0 and 1, and then we go to level 2 to control a system like a chemical plant, like a railway, like a production line. And then this is connected today to some, let's say, jump devices with which we do the control of this system, let's say, by supervisory. So supervisory systems we use here, and then we go to the office network where we have, for example, connections also to the OT. We will not find any industrial automation control system which do not have a connection to normal office, and with this also to the internet, where we, for example, want to have remote maintenance. That's in the environment we have to look at, and that has problems for itself, because we have to address, for example, safety, we have to address real-time systems like that. So that is what I want to address here. So, do you want to know the security status of the whole system? If you're the plant manager, I would say yes. But now we have to define what is the security status. So I do this definition for the security status because I want to clarify what is the security monitoring at the end. So we have to define this. See, there's a typing error. Okay, so security status defined. So the first is the security status describes the conformance agreement of a real system installed and operated, and we will call this system under consideration, with the rules and requirements defined for this system under configuration. That would be a security status. So you see, it's more than technique, because, for example, you have also processes. We discussed here security incident handling, something like that. We have to be compliant with legal requirements, all these things are introduced. So, an holistic view we have to look at. So if we look at the whole system, we have to look at 4 elements. This is done since, I would say, 2009. It was introduced by this small booklet, An Introduction to the Business Model for Information Security by Isaka. So it's not my idea, but I take this idea because I think it's really a holistic view. Because mostly people thinking about technology, some are thinking about processes, but sometimes organization is forgotten, and often persons are forgotten. And all 4 elements we need. So these 4 elements, but what can we do to get the security status that we can see that processes, persons, technology is according or is compliant with security rules the company has defined. So I assume that the company has defined these rules. Yeah? In often cases, it's only partially defined. So, okay, if we look at the organization and we want to evaluate the security status, the degree of conformity to security requirements, for example, for the organization, okay, we can do it only by audits. Okay, if we look at the element process, again, we can do it by audits. So that is something we cannot automate. Perhaps in processes we can automate it if we are able to define key performance indicators which can be measured automatically. Then it is possible, but it's not always for all phases in the processes. We are working on that a little bit at the moment to define that, because I have some students here which work on some topics of that. And at the end, I will put together the things which I get as a result of these works of the students. So thank you for that. Okay, so then the persons. Okay, we can do trainings, we can do some certifications of persons, and then that are our evidences we have to show that persons are according to security rules, or behave according to security rules. The last point is technology, and here we have the problem. Okay, at the moment we do it through audits. No? There are audit companies. I worked for audit company in former times, and so we had to do audits and to evaluate is the company according to these security rules or the IACS, the Industrial Automation Control System. So we have here thousands of elements, components we have to check normally. You cannot do it with audit on deep levels, down to configuration or something like that. So nobody will pay for that. So the question is, can we automate that? And that is my topic here now in this talk. Okay, what is the security status of the technology in an industrial automation and control system? So the other 3 elements, I forget at the moment about that. I focus now on technology. So, because in the moment we have the following problem, okay, we go as an auditor to a company, audit the technology for some system under consideration, for some industrial automation control system, and then we can say after 1 week, yes, we have some weaknesses and so on. And on the other side, the attacker is working with internet, computer, algorithms, tools you can find in the internet, the biggest the information knowledge base you can find, and all the tools you can find to use as an attacker. And the attacker can be a very experienced computer scientist. So you know that this is a very unequal situation, an unequal game. And if we are not able to automate the auditing or the evaluation of the security status for our technology, we are far behind the hacker. So in my opinion is we have to switch to some automation or to several parts of automation to check the audit, to check the security status of the technology we use. Okay, good. So the vision here now is the following. The vision is now for the technology element, the conformity of all components, including communication channels, with the defined security requirements is automatically monitored. That will be my view, my vision. Because, for example, in IEC 62443, they require a continuous security monitoring. And if you now look in the companies and see what is installed, you will find that there is no monitoring for security, or nearly nothing, in industrial automation control systems. Okay, so I can reformulate that closer to the component. We say, okay, if this is the vision, conformity of all components, with the defined security requirements, I can say the conformity of security configuration of all components, again, including communication channels, with the defined security requirements is automatically monitored. That will be the vision. And we are far away from that at the moment. That is my experience. So I worked on chemical plants, energy plants, production lines for different branches. So I think I have a little bit experience what is really the status typically in Germany or worldwide. Yeah. So it's like it is. Okay, so then that is quite different to security incident and event monitoring we have at the moment, for example, also in IT. What is the difference? If you do security event and incident monitoring or management, then you are evaluating the activities on the system or on the network. Sometimes they include security configuration parameters, but normally it's activities on the system. For example, failures in login, or what is the workload on some line? Is it normal or not normal? Things like that. Okay, so quite different from that would be that we really look in every component, what are the security parameters to define the security configuration of the component? And is this according to the security requirements the company has defined? I will make a very, very small and easy example for that. And then I think it's more understandable. So what are the necessary tasks? So we want to have this configuration conform to the defined security requirements. That is our goal. And that is the vision. Okay, so what task we have? We have some tasks which are preliminary, which are prerequisites that we can do that. So the first is identify what security requirements are relevant for which component. It's an effort to define that. But in principle, it's possible, and let's say we can do it more or less. Yeah, it's not the big challenge. Well, how we can do that? The normal way how we do that is we use risk analysis, threat analysis, or other security analysis, and or standards, or we use normally both. That is classical how it is now done in most companies. Okay, so a little bit like done. Then identifying security configuration parameters for all components within this system under consideration. So the question here is, which values for relevant parameters must be configured to achieve the information security requirements? So we have to define the parameters and the target values. I make an example then. So solvable in principle. We have here also support by the manufacturers, because they write normally something like a manual, and in this manual, if the manufacturer is mature to do that, then we have the parameters given and then the correct values for the parameters to have a good security configuration for the component. We did it, for example, for an industrial switch, and then we analyzed for this switch. I cannot tell you the name because no advertisement. So we run through all the parameters, then discussed what is the security requirements typically if this industrial switch is used in industrial automation control systems, and then we define the correct values. That was then the default secure configuration of this industrial switch. Okay, so we did that. So it's an initial effort, that's clear, and continuous effort of maintenance. If you, for example, change something in the switch, in the software, in the hardware, perhaps you have to include new parameters, or you have to correct the values for the parameters, things like that. So, one challenge is here. How are this data be made available so that it can be processed automatically by software or application? We have something like that. If you look at the network devices and you look at SNMP, then we have this database, Management Information Base, MIP, where you can find for this special device the parameters for CPU, for whatever. Okay? So more or less, it's in this direction, but it's only for one device. What we have to find here is we need something that I will explain, that some parameters have the same meaning or do not have the same meaning. We have to use that because otherwise we cannot build up our security requirements for all components. Okay, so then the next challenge, especially in industrial automation control system, is how can we get the current values of the parameters which we identified as relevant for security. Okay, in industrial environments, agents on components are often not allowed. If you look, for example, SNMP, an agent is running of an SNMP on an SNMP device, and then you can use that. By an SNMP server, you can say, okay, I want to get something, or you can push a command to the device. That's not possible here, because if we look at safety, you have to install like the product supplier, the manufacturer tells you. Otherwise, you lose the warranty, because here we have real-time communication and real-time systems. So we cannot change. No change. That means no installation of additional software or something like that. It's typically not allowed. So that is a problem here. And for some components, we can use that onboard tools we have, for example, for Windows. And I think here many specialists for different devices or components for Linux or other firmware, for example. And you can use that then. Why I take Windows at that point? Okay, if you look at the new installations in such environments, you will find that the big players like Amazon, Yokogawa, Siemens are using more and more Windows platforms. Not in the Purdue level 0 and 1, but in the Purdue level 2 and 3. So for supervising, for the control, they use that. For example, Active Directory or domain controllers and things like that. So if we start with Windows, learn from that, then a lot of components we can cover with that. So that would be the idea, to start with that. And, to be honest, okay, that's the easiest part at the moment, to address. Okay, good. Then we have to compare the actual value with the target value. This is the first idea. I will go into this a little bit deeper, but then we can check that. And if the target level is equal to the current level, actual level, then it's okay. If not, we have to send an event. So the difference between event and incident is, according to 27001, one or more events lead perhaps to an incident. So first we send an alarm for an event, and then we have to have some combination of events to send out or to get an alarm for an incident. And then incident would mean, okay, we have to handle it perhaps with a security incident handling process. Okay, good. For different components, we have to do that. Okay, if we look at these IACS, we have different components, about 100, things like that. So to do that, to make the comparison to the target value, we need something like normalization. Because not every parameter name means the same for the next component. Yeah? Like, for example, minimum password length. The name for this is different for different components. So we need a normalization to be able to do this check. So that is a large effort initially and for maintenance. So that is the program. What security requirements are relevant for which components? In principle, we can do that. Identify security configuration parameters for all components within the SUC. Again, big effort, but in principle solvable. Then the values for the relevant parameters must be configured to achieve conformity with the security requirements that are the target values we have to define. And then, yes, it switched. The relevant security parameters must be obtained regularly, but in this case, we do not have to look at time periods like milliseconds. It's enough to do it here, let's say, time periods of a few minutes. That's enough. So hopefully we get no problems with the network load in these environments. But in the real-time protocols and communication, that is a big question, and that is a challenge I cannot address at the moment. How can we do that? And we need for that companies with which we can work together here. No, because we need the experience for that. Otherwise, we cannot address that. So comparison then, actual value equals target value. If not, we have to send an event alarm. And then, okay, hopefully at the end we can visualize what is the security status of this component or of several components. And the vision would be for the whole IACS. Okay, back. So to the challenges. Simple and small example, configuration of password quality on Windows 11 client. I will tell a little bit and you will see how the work here explodes if you only look at one parameter, the password. Okay, we start here with a bachelor's thesis at the moment, which is done to learn something, how we can do that and how we can build parts of this let's say vision, but here with the smallest and easiest component at the beginning. Okay, so relevant parameters and values we can find out by SecEdit tool from Microsoft or Microsoft Service Security Compliance Toolkit and the corresponding baselines you can find in the internet and download. Then you get let's say, a proposal how to define the security configuration of your Windows 11 client. That is well known. That's nothing new. So example parameters, I take only a few for passwords. It's not all, only 4 here. Minimum password length, password complexity, maximum password age, password history size. minimum password length, I think you agree, you understand at once, yeah? So we need a minimum length of the password. Then we need some complexity. So normally it's alphanumeric, upper and lower capital case letters, and special signs. Huh? So now the discussion, what is the sufficient length of the password? Okay, we would have you discuss only for that point, huh? Normally. Huh? So, okay, then maximum password age is how often you have to change your password after what amount of days. And then password history size is you cannot reuse passwords you have used. And you can say here, for example, the last 10 passwords you are not allowed to use. That is well known. Okay, relevant parameters and values. Okay, according to a password policy. So what the student is now doing is he writes a password policy and then identifies the parameters in Windows 11 to enforce this policy with the right values. Okay? And this target or this relevant parameters and values we also need in a form which can be executed by a computer. Yeah? Otherwise, we are not able to do the automatic evaluation. So, for example, the password policy could be that we had to put in minimum password length 12, password complexity is 1. I come back to that. What is the meaning of password complexity in Windows 11 is equal to 1. We have to look what that means. And then maximum password age is here 90 days. So after 90 days, you have to change here the password. That is often done in companies as a password policy. And then password history size is here, for example, 10. Okay. So then automatic monitoring means we write a script which checks these parameters always. What is the current configuration? What is the security policy? And then we have the following gathering of information is easy with Microsoft onboard means, and normally you lose not the warranty if you use that. Then onboard means can be used. No? Development of a monitoring script is not really a rocket science. Yeah? That is only running through all the parameters and looking is the right value set. And then, but with any change of parameter names or values, we have to adapt the script. Oh? So a maintenance. And it could be that we have different parameters, different values for Windows 10, Windows 11, and so on. That is the challenge here, that we have to address all the components. Okay, challenge, but can be mastered. The password must be checked for different roles. Also, we have to look at that. What are the accounts? Do we have different password policies for that? All security parameters of Windows hardening have to be checked or first identified. For example, what allowed versions of installed software and so on. Okay, challenge for SUC, the next one. So password quality has to be checked for many different platforms like Windows client, Windows Server, Linux derivatives, QNX, VxWorks, real-time OS parts, or applications, PLCs, sensors, actors. If you want to include all the elements of an industrial automation control system. So large effort for the development and maintenance. And if we want to reduce that, we need otherwise it's impossible. We need some normalization. Okay, all security parameters of all different components, platforms, applications have to be checked. This is the challenge. Here's the example. Minimum password length is a parameter in Windows 11. And for example, if you look at Linux, Ubuntu, the same parameter name as the same is done by a parameter which has the name min_len by Ubuntu. So if you want now to check with your security policy where we have minimum length of password, then we have to map both parameters to this parameter, target parameter, minimum length, password. And that is what I mean with normalization. Okay. I addressed that, all actual security parameters for all different components, platforms, and so on have to be identified and then have to be obtained. How can that be obtained in IACS? That is for the Purdue level 0 and 1, so for the PLC sensor networks and things, is really a problem. If we go back to Windows environments where we have Purdue level 2 or 3, it's possible. Because, for example, in these environments, we do the patching with Vesus server of Microsoft. The things can be done. So we can do it here also on this level. One thing is important. Yes, we need test environments. If we really develop something, we have to test it in a test environment which is close to the real environment. Otherwise, we cannot get good results. So first steps. So that is a bachelor thesis for Windows 11. So definition of all security parameters and values. The student is working on that at the moment. Then development of a Python script in this case, obtain regular current values, check the values against the target values, visualize the security status. So that is the first step on the easiest case. And then testing and lessons learned, goals, get a good useful script and learn the next steps. Okay, then a new idea is answer set programming. At the moment, I do not know whether we will really get success with that. But the idea is, if we build up, let's say, something like for passwords for other parameters, all the values for all different components, what is it? That is a knowledge base. So knowledge-based knowledge, or working with knowledge, executable on computers, is one part of it. Artificial intelligence. I will not emphasize it strictly, but it is one part of that. So if you look now at the program, at this program answer set programming, that is a programming where you handle sets. For example, if we have this password and we have a set, an alphabet, a set of signs, an alphabet with which we can build up a password. That is a set of signs. And according to this answer set programming paradigm, we can manipulate or check sets. For example, is set A equal to set B? Things like that we can do here. So that was the idea to use that. So here's a really simple code. You can, for example, define some constants. Here I did it for the constant. The length of the password is, for example, 8 is configured, so I have to get that from the component, its current value. Then the mandatory is 8, for example, and I included also a test one. And then we have to put in the real alphabet, or let's say the set of signs which can used to build up a password. I did it only for 4 signs, A, B, C, D, which is the current value, so we have to get from the configuration, and here the mandatory which we get from the security policy. And now we can do some things with that, we manipulate that, and then we get here the logic. I will not go into deep here. And then we find out, for example, that the number of signs which are allowed by the security policy and are mandatory is, for example, equal to the elements we can find in the alphabet configured on the component. So that is the idea here. At the moment, I cannot say, can we make it then better than with the Python script? But I'm learning on that. Okay, so then normalization. How can we do normalization? The idea is that we have something like a knowledge base or a taxonomy. Taxonomy is built up by Thesaurus tools. So perhaps you can use this technique, to build up all our mappings from different names of parameters to one name with which we can work and do then the check. So because of that, I'm thinking about this Thesaurus technology. That would be the next step I want to do together with students. Because I have to give the students thesis, and if I have to do that, I will do a worthwhile work, so that I learn, the students learn, and perhaps we get a good result we can use in the next steps. That is my program here. So what we have to do here? Okay, define a set of security parameters. It's always the same, for example, for Windows, Linux, iOS, and other parameters. Then build up a thesaurus for the target parameters, including all the values, the target values, the target parameters, and then include the target values for the different components, and then define synonyms regarding these parameters for all the components. That should be easier to maintain, because if we have a new one, okay, put it in the taxonomy. Well, this is really easy. Or if the values change, okay, we can change it in the taxonomy. And then we can store it in XML format or whatever, and then it is usable or executable by the computer. So that is the idea here. So that we make this normalization manageable. We have to test that. Is it a good idea or not? Okay, then develop a program, obtain regularly the current values. That is always a problem we have to solve. So far, we have to get these values and parameters, then check the values against the target values, which are now, we can use now the synonym definitions here of this taxonomy. And then visualize the security status, and at the end, we make testing and lessons learned. So that is the program. And what I presented is a program for the next longer phase in my profession here at the THD. And hopefully I can fulfill step by step this program a little bit. So thanks a lot for your attention. And yes, I'm glad to answer your questions.